Okay, so good afternoon, everyone. Welcome to Physics 71. This is the 27th lecture. So we still have 5 lectures remaining. And the topic for today is on buoyancy. We'll just continue our study of fluid statics. So last time we discussed fluid pressure, and we know that from that lecture that fluid pressure varies with the depth from the surface. So of course you have absolute pressure, you have gauge pressure, but the point here is it's now dependent on the height of the fluid. Now, the question is, since there is a change in the pressure from the top of a surface and the object on the bottom of the surface, the question is, how does it affect the pressure on a certain object that's, for example, immersed or submerged on a fluid that's at rest. So, ang tanong doon, since may pressure difference, therefore may force difference, and therefore dapat may net force. 'Di ba? So that's basically what we mean by buoyant force or your buoyancy. Okay? So here's the objective for this topic. Our topic for today is just buoyancy. We'll just solve problems involving the buoyant force. And it turns out na marami tayong pwedeng isolve dyan. So at the end of this session, you should be able to basically use the concept of buoyancy and the Archimedes Principle in various systems involving fluids and objects in fluids. So if there's an object that is partially immersed or fully submerged on a fluid, what happens is there are 3 possible cases. Pwedeng lumubog yung object, pwedeng lumutang yung object, or pwedeng andun lang siya fully submerged. So yun. So ang tanong dito is, alin yung mga conditions para ganun yung mangyari? Okay, but before that, let's go to some history, a very little bit of history. So there's a Eureka Moment. During the 1st century BC, Hero II, the king of Syracuse, suspected that the goldsmith might have replaced some of the gold given to him with silver. So pinatawag niya yung pinakamagaling niyang mga assistant, and it turns out na para ma-check kung yung gold, I think this is a gold crown, if I remember correctly. This is a gold crown. Kung yung crown na meron siya ay gold o hindi. So now the question is it gold or not? Ang ginawa is they immersed this object in water, and it turns out na okay. And Hero asked Archimedes to find out whether the wreath was a wreath pala siya. This pala siya crown. Inisip ko ay crown eh. Sorry for that. The wreath was pure gold, and it turns out that okay, when it is immersed in air, the crown and the gold have equal weights, equal masses in that case. Pero nung immerse siya sa tubig, the ground displaced more water than the gold. So the reason for that is that the crown displaced more water than the gold, pero sa air kasi masyadong maliit yung buoyant force ng air, hindi masyadong makikita or hindi masyadong apparent yung buoyant force due to air. And it turns out that from this moment, he has a eureka or surprise moment. Nakahubad pa siya noon, takbo-takbo siya sa king, and turns out kay Hero II, takbo-takbo siya. Oh, I found that it's actually that's the result is that okay, so any object wholly or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. Okay, that's what's known as your Archimedes principle. So yun, so from an accidental discovery, we get what we will now known as your Archimedes principle. Okay. Now, so which is also related to your buoyancy. So buoyancy is the apparent loss of weight of objects when submerged in a fluid, because there is an upward force that is exerted by the fluid on the object. So kaya dapat meron kang weight loss na nangyayari. So when you measure for example the tension exerted on an object that is hung, tapos in-immerse mo yung object na yun sa tubig or sa kung anumang fluid, there is the tension that you will get is much less than the actual weight of an object. So there's an apparent weight loss that's happening. Okay, so the buoyant force is the net upward force exerted by a fluid on a submerged or immersed object. So as I said, saan siya galing? Ang tanong ngayon doon ay saan galing yung buoyant force na yan? The question is, why is it an upward force? Okay, pwede mong isipin na there is a difference in pressure at the top of the object and at the bottom of the object. Okay, let's have some calculations. Okay, remember that this object here is static. Ibig sabihin, since the fluid here is static, dapat hindi mag-accelerate downward yan. Okay? So when you do Newton's second law about the center of mass of this fluid volume here, then the net sum of all forces should be 0. Kasi nga, dapat hindi dapat mag-accelerate downward yan, otherwise edi lulubog yung object. So So in that case, summation of forces acting on y is 0. And then the question is, what are the forces acting on this fluid volume here? So what are the forces? May tatlo. First, may force na ina-exert yung surface ng fluid at the top. Second, may force na ina-exert yung bottom ng fluid, which is upward. So the force exerted at the top is downward. The force exerted by the bottom is upward. Tapos syempre may weight yung fluid volume, which is given by some mass times acceleration due to gravity. So parang ganyan. So if you're assuming here that this is this is a cube of fluid, pwede namang hindi. In general, hindi yan totoo. But the point here is we can calculate that fluid here, the weight of the fluid here. And it turns out that the difference in the forces exerted at the top and at the bottom of the fluid is equal to the weight of the fluid displaced. And from there, remember that force is just pressure multiplied by area. Diba? It's just pressure multiplied by area. So that difference in the forces that are exerted from the bottom, by the bottom and by the top is your buoyant force. And therefore, kung wala itong weight na to, dapat merong upward force sa mag-exert dun sa fluid. Okay? Clear ba yon? Clear ba tayo dito? So therefore, there should be an upward force to counteract the force exerted or by the earth on the object or the weight of the fluid column. Okay? Questions? Kaya meron ka dapat. Okay, tama. So F2 minus F1 here, meaning that the force exerted by the bottom is greater than the force exerted by the top. Kaya upward yung magiging force mo, hindi pwedeng maging downward yan. And the buoyant force is just the density of fluid times the volume of the submerged fluid times the acceleration due to gravity. Saan ang galing yan? Pwede mong isipin na F2 minus F1 is simply, so pwede mong isipin yan na pressure at the bottom, A, minus pressure at the top, A. Tapos pwede mong isipin na this is just pressure at the bottom minus pressure at the top multiplied by A. And from there, lalabas na, medyo short, this is simply density at the bottom times G times H times distance at the bottom minus the density at the top, G times distance at the top multiplied by A. Tapos, pwede mong isipin na yung density at the bottom at saka density of the top. Parehas lang naman yan. It's the same fluid. Therefore, this is density of the fluid times G times this D here. What is D bottom minus D top? Well, technically, it should be H bottom minus H top, or the difference in the distance in the height. So if this is the height at the bottom, it's the height at the top, and this is the height at the bottom, then their difference is just the total height of the fluid column. So this is just the height of the fluid column times A. Pero ano yung height times A na yan? Ano lang yan? That's the total what?
Volume.
Yes, that's the total volume. Therefore, you get density of fluid, volume of the fluid times G. Nakuha? Kaya nakuha mo tong rho F equals rho F V sub G. Gets? Gets ba? Nakuha? Sir, wait. Paano kapag pinilitan ko yung fluid column ng isang object? Actually, it doesn't matter. Kasi what happens is, the only important here, before we go to that pala, buoyant force is a result of the pressure difference at the top and the bottom. So from here, we have shown the calculation, and it turns out that the buoyant force is simply rho fluid, V fluid, multiplied by G. Okay? So this is, again density of fluid, not density of object. Wag malilito dyan. Marami nalilito dyan. Even ako minsan nalilito dyan. It's the density of the fluid, not the density of the object. Okay. Now, so again, buoyant force is a result of the pressure difference at the top of the bottom. Since mas malaki ang pressure sa bottom, therefore, mas malaki yung force na in-exert ang bottom compared to the top, and therefore, the net sum of forces of these two pressures, due to the difference in the pressure, is also upward, and hence, the buoyant force is upward. Yun lang naman yung gustong sabihin nun. And the formula is rho fluid V submerged G. Okay? Sige. Now, let's clarify. So, what if palitan ko yung fluid volume na to ng isang object? Actually, it doesn't matter. ang kailangan mo lang napalitan para same yung buoyant force mo is the volume should be the same, not necessarily the weight. Okay? Hindi lalabas yung weight usually sa equation to unless that volume of the fluid is equal to the volume of the object. That only happens when the object is fully submerged. Ibig sabihin, yung lahat ng parts ng object nakalubog. Okay? So, in general, it is the volume of the fluid displaced that you need to use or the volume of the submerged object. Kung ano lang yung nakababa. Okay? Yung importansya ng equation to. Simple equation pero marami nalilito. Again, the buoyant force only depends on the density of the fluid, not necessarily on the density of the object displaced. Of the object immersed or submerged. Ang importante dito ay yung fluid na dinisplace, hindi yung object na nilagay. Okay, now the density of object will also come into play if we substitute the volume of the object with the density of the object, which we will see in some problems that we will be solving. Okay, so yun lang kailangan mo tandaan dito. All you need to do in this topic is use Newton's second law about the center of mass of the fluid column or of the object, and then use the equation for the buoyant force. Treat buoyant force as another type of force. Yun lang isipin nyo. Okay, questions? May tanong? May tanong ba? Wala?